In a vast theater of cosmic events that capture humanity's fleeting attention, most celestial phenomena follow a predictable arc. They burst into public consciousness with spectacular fanfare, dominate headlines for their brief moment in the cultural spotlight, and then fade gracefully into the archives of astronomical history, relegated to academic papers and specialist discussions. This is the natural rhythm of how we process the universe's wonders in our modern information ecosystem. We observe, we marvel, we catalog, and then we move forward to the next curiosity that beckons from the infinite darkness above. But 3I Atlas, formally designated as an interstellar object that entered our solar system's domain, has proven itself to be a profound exception to this established pattern. This object, this cosmic visitor from the depths beyond our stellar neighborhood, stubbornly refuses to slip quietly into the background noise of forgotten news cycles. Despite the concerted efforts of mainstream media organizations to declare the story concluded, to assure the public that all questions have been satisfactorily answered and that it is time to redirect our attention toward more pressing terrestrial concerns, 3I Atlas continues to assert its presence in ways that demand ongoing scrutiny and serious investigation. The reasons for this persistence are manifold and deeply troubling to those who prefer their universe orderly and explicable. We are not merely dealing with lingering public curiosity or the conspiracy-minded refusing to accept official explanations. Instead, we are confronted with tangible, observable, scientifically documented phenomena that continue to emerge, each new data point adding another layer of mystery to an already perplexing situation. The CIA connection, when intelligence agencies take notice. Most remarkably, and most recently, new information has surfaced that involves an organization not typically associated with astronomical observations or the study of comets and asteroids. The Central Intelligence Agency, America's premier foreign intelligence service, an organization whose mandate centers on national security threats, covert operations, and the protection of American interests against adversaries both terrestrial and, apparently, potentially otherwise, has become entangled in the 3I Atlas narrative in ways that raise profound questions about what this object truly represents. The mere fact that the CIA appears in this story at all should give any thoughtful observer pause. This is not an agency that concerns itself with routine astronomical phenomena. The CIA does not typically devote resources, personnel, or classified attention to standard comets, no matter how interesting they might be to professional astronomers or amateur stargazers. Their involvement suggests something beyond the ordinary, something that intersects with their core mission in ways that remain frustratingly opaque to public understanding. This CIA connection is not speculative or based on rumor. It emerges from official channels, from the formal mechanisms of governmental transparency that allow citizens to request information from their government. This development alone justifies renewed attention to 3I Atlas, regardless of how many times we are told to move along and accept the conventional explanations that have been offered. New photographic evidence, the anti-tail phenomenon. Beyond the intelligence community's mysterious interest, we also have fresh observational data that continues to document 3I Atlas's peculiar behavior. Less than a week ago, as measured from the time of this investigation, the Virtual Telescope Project, a respected astronomical observation initiative that provides public access to professional-grade telescopic observations, captured a new photograph of this object. To the casual observer, this image might appear entirely unremarkable. It shows what seems to be an ordinary comet, the kind of celestial ice ball that has visited our inner solar system countless times throughout Earth's long history, trailing its characteristic tail of sublimated material as it approaches the sun's warmth. But appearances, as is so often the case in both human affairs and cosmic mysteries, can be profoundly deceiving. What this photograph actually documents is something far more anomalous, something that continues to challenge our understanding of how interstellar objects should behave when subjected to the known forces that operate within our solar system. This image captures a mysterious interstellar visitor that continues to generate what astronomers call an anti-tail, a tail that extends in a direction that fundamentally defies the expected influence of solar radiation pressure and the solar wind. To understand why this matters requires grasping some basic principles of cometary physics. When a comet approaches the sun, the increasing temperature causes the frozen volatiles within its nucleus to sublimate, transforming directly from solid ice to gas without passing through a liquid phase. This outgassing creates the characteristic tail that makes comets such spectacular objects for observation. However, this tail always points away from the sun, pushed outward by the solar wind, that continuous stream of charged particles that flows outward from our star in all directions. This is not a sometimes phenomenon or a general tendency. It is an iron law of solar system dynamics, observed in every conventional comet ever studied throughout the entire history of astronomy. Yet 3I Atlas produces an anti-tail that extends in the opposite direction, toward the sun rather than away from it. This anti-tail is not some minor appendage or barely detectable feature that might be dismissed as an observational artifact or a trick of perspective. It extends outward to a distance of at least 500,000 kilometers, a distance that is difficult to conceptualize in human terms, but which represents a substantial fraction of the distance between the Earth and our moon. In some observations, this anti-tail has been documented extending even further, reaching distances of up to 1 million kilometers, which actually exceeds the Earth-Moon separation. This is not a trivial anomaly. This is not something that can be easily explained away with minor modifications to existing cometary theory. An anti-tail of this magnitude, persisting over extended observation periods, represents a fundamental challenge to our understanding of how these objects should behave when subjected to the known forces operating within our solar system. The mounting list of unexplained phenomena. This anti-tail phenomenon, as striking as it is, represents merely one item in a growing catalog of characteristics associated with 3I Atlas that have yet to receive satisfactory explanation from the astronomical community or from the space agencies tasked with monitoring near-Earth objects and potential threats from space. Each of these unexplained features might, in isolation, be dismissed as an interesting anomaly, a minor puzzle to be resolved with further observation and refined theoretical modeling. But taken together, they form a pattern that suggests something more profound may be occurring. These are not questions that can be casually set aside in the interests of moving forward to other astronomical priorities. These are fundamental issues that strike at the heart of what 3I Atlas actually is and where it came from. Before we allow this object to simply continue on its trajectory through the galaxy, assuming, of course, that it actually does follow a predictable gravitational path out of our solar system and back into interstellar space. These questions demand answers. They require the kind of rigorous, sustained scientific attention that is typically reserved for phenomena that challenge our foundational understanding of physical processes. The stakes here are not merely academic. We are not simply talking about refining our models of cometary composition or updating our catalogs of orbital mechanics. If 3I Atlas is indeed something other than a conventional natural object, if it represents technology or intentional design rather than the random aggregation of ice and rock, then our failure to recognize this fact could have implications that extend far beyond the realm of astronomical curiosity. The Freedom of Information Act request, pulling back the curtain. It is against this backdrop of ongoing mystery and unanswered questions that a Freedom of Information Act request was submitted to the Central Intelligence Agency by an organization that has established a well-earned reputation for responsible investigation of unexplained phenomena. This organization, which operates under the name the Black Vault, is not some fringe conspiracy collective given to wild speculation and evidence-free theorizing. Rather, it is an entity that has devoted years to the careful, methodical examination of government documents related to UFOs, unexplained aerial phenomena, and other mysteries that exist at the intersection of official secrecy and public curiosity. The Black Vault has distinguished itself by adhering to rigorous standards of evidence and documentation. They do not traffic in rumor or unverified claims. They do not amplify sensationalistic interpretations or leap to conclusions unsupported by the documentary record. Instead, they pursue official channels, submit formal requests through established legal mechanisms, and report on what the documents actually say rather than what might make for more exciting headlines. This approach has made them a trusted resource for anyone seeking factual, non-sensationalistic information about topics that too often become obscured by misinformation and overheated speculation. When the Black Vault submits a Freedom of Information Act request, it carries weight. It represents a serious effort to obtain official documentation about subjects that government agencies might prefer to keep away from public scrutiny. The response that the CIA provided to the Black Vault's inquiry about 3I Atlas came as a genuine shock to observers who have followed these matters for years and who have developed a sophisticated understanding of how intelligence agencies communicate, or more often, decline to communicate about sensitive subjects. Decoding the response, what the CIA actually said. The response from the CIA was, on its surface, unsurprisingly uninformative. This is precisely what anyone with experience in government transparency requests would expect from an intelligence agency whose institutional culture revolves around compartmentalization, classification, and the careful control of information. The CIA does not readily volunteer details about its operations, its interests, or its intelligence-gathering activities. This is understood and, within the context of legitimate national security concerns, often appropriate. However, and this is the crucial point that requires careful attention, the CIA did not say that they have no information about 3I Atlas. They did not claim that they have never investigated this object or devoted any resources to understanding its nature and potential implications. They did not issue the kind of flat denial that intelligence agencies routinely provide when they truly have no involvement in or information about a particular subject. Instead, they said something very different, something that in the specialized language and historical context of CIA communications actually constitutes an acknowledgement that 3I Atlas is indeed a subject that falls within their classified domain. Understanding what the CIA actually communicated requires familiarity with the historical patterns of intelligence agency responses to Freedom of Information Act requests. It requires knowing what certain formulations actually mean within the specialized discourse that these agencies employ when walking the fine line between legal obligations to respond to legitimate public inquiries and their institutional mandate to protect classified information. This is not a matter of reading between the lines or engaging in speculative interpretation. Rather, it involves recognizing established patterns in how these agencies communicate about subjects that touch on classified matters. If the CIA truly had no information about 3I Atlas, if they had never investigated it, never tasked any surveillance assets with observing it, never conducted any assessment of whether it might represent any kind of security concern, they would have simply stated that they possess no responsive documents. This is standard practice for subjects that fall outside their operational purview. They would have issued a brief, bureaucratic response indicating that a search of their records revealed no documents matching the request parameters, and that would have been the end of the matter. But that is emphatically not what they said. Instead, they issued what is known in Freedom of Information Act circles as a GLOMAR response, a specific type of refusal that carries significant implications for anyone who understands its history and its typical application. The GLOMAR precedent: neither confirm nor deny. The term GLOMAR response has its origins in a fascinating episode of Cold War history that perfectly illustrates the kinds of situations where intelligence agencies find themselves caught between conflicting imperatives. The name derives from the Hughes Glomar Explorer, a ship that was involved in a covert CIA operation codenamed Project Azorian. This was one of the most ambitious and expensive covert operations ever undertaken by American intelligence services, an effort that remained successfully hidden from public awareness for years despite involving hundreds of personnel and massive logistical complexity. The objective of Project Azorian was extraordinarily audacious. In 1968, a Soviet ballistic missile submarine designated K-129 had sunk in the Pacific Ocean under circumstances that remained unclear to both Soviet and American naval intelligence. The submarine came to rest on the ocean floor at a depth of approximately 3 miles, far beyond the reach of conventional salvage technology of that era. The vessel contained codebooks, nuclear torpedoes, encryption equipment, and potentially intact examples of Soviet missile technology, a treasure trove of intelligence that the CIA desperately wanted to examine. The Hughes Glomar Explorer was constructed under the cover story that it was a deep-sea mining vessel being developed by the eccentric billionaire Howard Hughes to harvest manganese nodules from the ocean floor. This cover story was elaborate and meticulously maintained, involving genuine mining equipment and public demonstrations of supposed commercial mining interests. In reality, the ship was equipped with a massive claw-like capture device capable of reaching the ocean floor, grasping the submarine's hull, and lifting it toward the surface. The operation took place in 1974, and by most accounts managed to recover at least a portion of the submarine, though exactly how much remains a subject of debate even decades later. The entire project remained classified until investigative journalist Jack Anderson began asking questions about it in 1975. When news organizations subsequently submitted Freedom of Information Act requests asking for CIA documents about the Glomar Explorer and its activities, the agency found itself in an impossible position. If they denied having any documents, they would be lying, which would violate federal law and potentially expose agency personnel to criminal liability. If they admitted to having documents, they would be confirming the existence of a highly classified operation, effectively declassifying it through acknowledgement. The solution they developed was to neither confirm nor deny the existence of responsive records, arguing that even acknowledging whether or not such records existed would itself reveal classified information. This approach was tested in court in the case of Philippi versus CIA in 1976, where judges ultimately upheld the agency's right to use this formulation under specific circumstances. The legal standard that emerged from this and subsequent cases established that a Glomar response is appropriate when the very fact of having or not having records would itself disclose classified information that is properly protected under one of the Freedom of Information Act statutory exemptions. When Glomar responses are actually used, it is essential to understand that a Glomar response, from a strictly legal and theoretical perspective, does not automatically and definitively mean that the CIA possesses records responsive to the request. Courts have recognized that such a response could theoretically be appropriate, even if no records exist, provided that admitting the absence of records would itself reveal protected information about intelligence priorities, capabilities, or operations. For instance, consider a hypothetical scenario where someone submits a Freedom of Information Act request asking for all CIA records concerning surveillance of a specific foreign diplomat. If the CIA were to respond that they have no such records, that denial would itself constitute an intelligence disclosure. It would confirm that this particular diplomat is not currently under CIA surveillance, which could be valuable information to that diplomat's government. It might indicate that the CIA does not consider this individual to be of intelligence interest, or that they are employing surveillance methods that do not generate the kinds of records that would be responsive to such a request. Any of these inferences could compromise ongoing operations or reveal gaps in CIA coverage that adversaries might exploit. Therefore, in such cases, the CIA might legitimately employ a Glomar response, even if they truly have no records, because the admission of having no records would itself reveal classified information about their operational priorities and activities. This theoretical possibility must be acknowledged as part of any honest analysis of what a Glomar response actually means. However, and this is where historical pattern analysis becomes crucial, in actual practice, across decades of Freedom of Information Act litigation and thousands of requests submitted to intelligence agencies, Glomar responses are overwhelmingly associated with situations where records actually do exist and where their acknowledgement would be problematic for classification reasons. This is not speculation or assumption. It is a pattern derived from cases where GLOMAR responses were later successfully challenged, partially declassified, or subsequently revealed through other disclosure mechanisms. Agencies are not required to use a GLOMAR response when they genuinely have nothing. In a vast majority of cases where an intelligence agency truly has no involvement in or information about a particular subject, they simply say so. There is no classification harm in admitting that you know nothing about an unremarkable subject that falls outside your operational mandate. The choice to invoke GLOMAR protections, rather than simply denying possession of records, typically signals that the subject matter touches on areas where the agency does indeed have classified interests, information, or activities. The 3I Atlas GLOMAR. Analyzing the specific response. The formal Freedom of Information Act request submitted by the Black Vault was assigned the tracking number F 2026-00-00231. It was submitted to the CIA on November 12, 2025, a date worth noting as it came relatively early in the period when public and scientific attention was intensely focused on 3I Atlas. The request was carefully crafted to seek any assessments, reports, or communications maintained by the Central Intelligence Agency referencing 3I Atlas or Interstellar Object 3I Atlas from June 1, 2025 until the present. This time frame is significant. June 2025 would have been approximately when 3I Atlas first came to widespread attention in astronomical circles, when its unusual characteristics first began to be documented and discussed in scientific venues. By requesting documents from this period forward, the Black Vault was effectively asking for any CIA materials generated during the entire period of 3I Atlas's transit through the inner solar system, any period during which the intelligence community might have taken interest in this object. On December 31, 2025, the final day of that year, the CIA issued its response. The timing itself is somewhat interesting, as year-end releases sometimes reflect agencies trying to clear their FOIA queues before annual reporting deadlines, though reading too much into the specific date is probably unwarranted. What matters is the content of the response itself. The CIA stated, and I quote the language precisely because precision matters enormously in these contexts, "We completed a thorough review of your request and determined that in accordance with Section 3.6a of Executive Order 13526, the CIA can neither confirm nor deny the existence or non-existence of records responsive to your request. The fact of the existence or non-existence of such records is itself currently and properly classified and is intelligence sources and methods information protected from disclosure by Section 6 of the CIA Act of 1949. This is textbook GLOMAR language, invoking the specific legal authorities that the CIA believes justify their refusal to provide any information. Executive Order 13526, signed by President Obama in 2009, governs the classification system used throughout the federal government. Section 3.6a specifically addresses the use of what are called classification challenges, the mechanisms by which agencies can protect information from disclosure. Section 6 of the CIA Act of 1949, meanwhile, is one of the agency's fundamental statutory protections, shielding intelligence sources and methods from public disclosure even when other transparency laws might otherwise require release. The invocation of these specific authorities tells us that the CIA is asserting that even acknowledging whether they have information about 3I Atlas would compromise intelligence sources and methods. This is an extraordinary claim when we consider that we are ostensibly talking about a natural comet, an astronomical object that poses no threat and has been the subject of extensive public scientific observation using civilian telescopes and published research. The Black Vault's response, pressing forward. John Greenwald, the founder and driving force behind the Black Vault, has already announced publicly that he is appealing this denial. This is significant for several reasons. First, it indicates that someone with extensive experience in Freedom of Information Act requests and CIA response pattern believes there is something worth pursuing here. Greenwald has submitted hundreds, perhaps thousands of such requests over his years of operating the Black Vault. He has seen every type of agency response, every bureaucratic dodge, every legitimate and illegitimate assertion of classified privilege. When someone with that depth of experience decides that a particular response warrants the time and effort required to file an appeal, a process that involves drafting detailed legal arguments, marshaling evidence, and potentially preparing for litigation, it suggests they believe there is a reasonable likelihood of obtaining additional information or at least forcing the agency to provide more detailed justification for its secrecy. The appeals process for denied Freedom of Information Act requests is not simple or quick. It requires making specific arguments about why the agency's claimed exemptions do not apply or were improperly invoked. It may involve multiple rounds of administrative review before any potential court filing. The fact that the Black Vault considers this worthwhile indicates their assessment that the CIA's Glomar response, in this particular context, may be vulnerable to challenge or may itself reveal something significant about the agency's interest in 3I Atlas. The comparative anomaly. Why 3I Atlas and not the others? One of the most intriguing aspects of this entire situation emerges when we consider which interstellar objects have prompted Freedom of Information Act requests and which have not. The astronomical community has identified multiple objects in recent years that have entered our solar system from interstellar space, following hyperbolic trajectories that clearly indicate they originated from beyond our sun's gravitational influence. The most famous of these, prior to 3I Atlas, was Oumuamua, which was discovered in October 2017 and became the first officially recognized interstellar object to pass through our solar system. Oumuamua itself displayed extremely unusual characteristics that sparked considerable debate within the astronomical community. Its elongated shape, its unexpected acceleration as it moved away from the sun, and its lack of any visible cometary outgassing all contributed to speculation about its nature. Dr. Avi Loeb, chair of Harvard's astronomy department, notably argued that Oumuamua's characteristics were at least consistent with artificial origin and deserved serious consideration as a possible probe or artifact from an extraterrestrial civilization. Despite all of this attention, despite the scientific papers and public discussions and media coverage, the Black Vault apparently never submitted a Freedom of Information Act request to the CIA specifically about Oumuamua. Similarly, 2I/Borisov, the second recognized interstellar visitor, which arrived in 2019 and displayed more conventional cometary characteristics, also did not prompt such a request. So why 3I Atlas? What about this particular object motivated the Black Vault to submit formal documentation requests to intelligence agencies when previous interstellar visitors did not warrant such attention? This question has no publicly available answer, but it is deeply suggestive. It implies that something about 3I Atlas, whether specific observational characteristics, patterns in how government agencies were discussing it, or information obtained through other channels, made this object seem particularly worthy of investigation through official transparency mechanisms. One can only speculate about what might have triggered this decision, but the fact that experienced investigators of government secrecy found 3I Atlas uniquely worthy of formal inquiry adds another layer of significance to an already mysterious situation. Avi Loeb's perspective, questioning the contradiction. Dr. Abraham Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University and one of the most prominent voices calling for serious scientific consideration of the possibility that some anomalous objects might have technological origins, has weighed in on the CIA's Glomar response with observations that cut to the heart of the contradiction embedded in the official narrative surrounding 3I Atlas. Dr. Loeb points out what should be obvious to any careful observer. There is a profound mismatch between NASA's public posture regarding 3I Atlas and the CIA's assertion that even acknowledging whether they have information about this object would compromise classified intelligence sources and methods. This is not a minor inconsistency or a bureaucratic quirk. It represents a fundamental contradiction that demands explanation. NASA officials stated clearly and definitively at a press conference held on November 19, 2025, that 3I Atlas is unquestionably a comet of natural origin. They did not couch this in tentative language or present it as a preliminary conclusion subject to revision pending further data. They presented it as established fact, as the clear and obvious reality that should be accepted by anyone engaging with the evidence in good faith. The tone and substance of NASA's presentation suggested that there should be no ongoing mystery, no legitimate questions about what this object is. It is a comet, they assured us, natural and unremarkable despite some of its unusual observational characteristics. If this conclusion was indeed as clear and unambiguous as NASA presented it, if everyone within government and academia agreed that 3I Atlas is simply a natural comet with some interesting but ultimately explicable properties, then why would the CIA treat the potential existence of records about this object as so sensitive that even acknowledging whether such records exist would reveal classified intelligence information? This is not a rhetorical question posed for dramatic effect. It is a genuine logical problem that requires resolution. Natural comets, regardless of their origin or observational characteristics, are not typically subjects of intelligence classification. The CIA does not generally involve itself in astronomical matters unless there is some nexus with national security concerns. If 3I Atlas truly is nothing more than a comet, albeit one with unusual properties, then CIA interest would be puzzling at best and actively suspicious at worst. Dr. Loeb's question essentially asks us to consider which official position we should believe. Either NASA is correct that this is clearly a natural object of no special significance beyond academic interest, in which case CIA classification makes no sense, or the CIA's assertion of sources and methods privilege is appropriate, in which case NASA's confident dismissal seems premature at best and potentially misleading at worst. Both cannot simultaneously be true. If 3I Atlas is an ordinary natural phenomenon, there is no legitimate sources and methods justification for refusing to disclose whether the CIA has looked at it. If there is a legitimate classification basis for GLOMAR protection, then it cannot simultaneously be true that everyone in government agrees this is simply a natural comet with no security implications. The SETI observation, what radio silence actually means. Dr. Loeb's public comments on the CIA response also addressed another recent development in the 3I Atlas investigation. Efforts by the Breakthrough Listen initiative to detect any radio signals emanating from this object that might suggest technological origin or active transmission capabilities. The search for extraterrestrial intelligence, commonly known as SETI, has long focused primarily on detecting signals from distant star systems, looking for evidence of technological civilizations across interstellar distances. The opportunity to point radio telescopes at a potential interstellar visitor within our own solar system represents a unique chance to search for technosignatures at far closer range than is normally possible. According to new data from these SETI observations, no narrowband radio transmissions were detected from 3I Atlas during a 5-hour observation window that took place between 04:15 and 09:15 UTC on December 18, 2025. Narrowband transmissions are considered particularly significant in SETI work because natural astronomical processes typically produce broadband radio emissions across a wide range of frequencies, whereas artificial transmissions tend to be concentrated in narrow frequency bands to efficiently convey information. The absence of detected narrowband signals might seem, at first consideration, to be strong evidence against the hypothesis that 3I Atlas is anything other than a natural object. However, as Dr. Loeb correctly notes, this inference is far from straightforward. The expectation that a technological object should transmit radio signals in ways that we can readily detect rests on a series of assumptions about the purposes, capabilities, and operational protocols of any hypothetical probe or artifact. These assumptions may or may not be valid. Consider first the question of communication with a distant origin point. If 3I Atlas were indeed some form of probe or monitoring device sent by an extraterrestrial civilization, would it necessarily maintain regular contact with its creators through radio transmissions? The timescales involved in interstellar communication make such contact potentially pointless for anything resembling real-time information exchange or operational control. Radio signals travel at the speed of light, which means that a transmission from 3I Atlas to a civilization located even relatively nearby in galactic terms, say a few hundred light-years away, would take centuries to arrive. If the origin point is located near the galactic core, which some trajectory analyses have suggested as a possible direction of origin for 3I Atlas, we will be discussing transmission times of tens of thousands of years. Even if we consider distances as short as a few dozen light-years, representing some of our nearest stellar neighbors, we are still talking about communication delays that span human lifetimes. Under these circumstances, what would be the purpose of continuous or even regular radio transmission back to the point of origin? By the time any response could be received, the probe would have long since departed our solar system and moved on to other destinations. The civilization that sent it might have evolved beyond recognition or even ceased to exist. The galaxy would have turned through a significant fraction of its rotation. Any information transmitted would be historical data only, useful perhaps for some eventual comprehensive record, but serving no operational purpose for the probe itself. Dr. Lowe points out that the time 3I Atlas is spending within our solar system, assuming its velocity remains constant and it follows a hyperbolic escape trajectory, is approximately 16,000 years. This figure represents the object's travel time from the outer reaches of the Sun's gravitational influence through the inner system where Earth and the other terrestrial planets orbit, and back out to interstellar space. Over the timescales of the galaxy's rotation and evolution, 16,000 years is essentially instantaneous. For context, such a journey represents less than 1/10,000th of the time the human civilization has existed on Earth, and a microscopic fraction of the time required for signals to traverse significant galactic distances. Given these temporal realities, it would make little sense for an efficient, resource-constrained probe to continuously broadcast radio signals to its creators. Such transmissions would consume energy, whether from solar panels, an onboard power source, or some other mechanism, without providing any practical benefit during the probe's active mission phase. A more logical approach, if communication with the origin civilization were indeed a priority, would be to compress data into short, high-energy bursts transmitted at long intervals or at specific milestones in the mission. Such an approach would minimize energy expenditure while still potentially returning data to the creators over the vast timescales inherent to interstellar projects. The limitations of 5-hour observations. The SETI observations of 3I Atlas, while valuable and worthy of undertaking, suffer from severe limitations that must be acknowledged when assessing what their null result actually tells us. The observation window was just 5 hours, a mere snapshot in time during which radio telescopes were pointed at 3I Atlas and listening across a range of frequencies for any narrowband signals that might indicate artificial transmission. 5 hours represents a minuscule fraction of the time that 3I Atlas has been accessible to observation within our solar system. If the object is indeed employing some form of intermittent communication protocol, transmitting perhaps once per day, once per week, or at even longer intervals, the probability that a 5-hour observation window would happen to coincide with such a transmission is correspondingly tiny. It would be analogous to watching a lighthouse for 5 minutes out of an entire year, and, upon seeing no light flash during that brief period, concluding that the lighthouse does not produce light. Furthermore, as Dr. Loeb emphasizes, any signal from 3I Atlas might not be transmitted in the direction of Earth at all. If the object were indeed communicating with its origin civilization, and if that civilization is located in a direction substantially different from Earth's position relative to 3I Atlas, then the transmission might be tightly beamed in that direction to conserve energy and maximize signal strength over interstellar distances. A beam transmission pointed away from Earth would be undetectable to our radio telescopes regardless of how long we observed or how sensitive our equipment might be. The frequency range monitored during these SETI observations, while carefully chosen based on current theoretical understanding of what frequencies might be preferred for interstellar communication, still represents only a tiny slice of the electromagnetic spectrum. If 3I Atlas were transmitting at frequencies outside the monitored range, perhaps using parts of the spectrum that we have not anticipated, or employing communication technologies that do not rely on radio waves at all, then our observations would reveal nothing. A truly comprehensive observing program, as Dr. Loeb notes, would need to monitor 3I Atlas from multiple vantage points, covering different angles and directions, over an extended period of time that encompasses a substantial fraction of the object's transit through the inner solar system. Such a program would ideally employ multiple radio telescopes distributed geographically to provide continuous coverage, and would scan across the widest possible range of the electromagnetic spectrum. Even then, null results would not definitively rule out the possibility of artificial origin, as there is no reason to assume that any extraterrestrial technology would necessarily employ radio communication in ways that we would recognize or anticipate. The unasked question: what did the CIA actually observe? This discussion of the limitations of public SETI observations raises a question that cannot be answered with currently available information, but which looms large over this entire situation. Did the Central Intelligence Agency conduct its own observations of 3I Atlas? And if so, what did those observations reveal? The CIA has access to surveillance capabilities that far exceed anything available to civilian astronomers or even to NASA's scientific missions. These include classified reconnaissance satellites with optical and other sensing systems whose capabilities remain closely guarded secrets. Some of these systems were originally designed for observing military installations, missile tests, and other strategic targets on Earth, but their optics are equally capable of observing astronomical targets when tasked to do so. We know from historical precedent that intelligence community assets have been used for astronomical purposes when deemed appropriate. During the Cold War, reconnaissance satellites were occasionally tasked to observe Soviet spacecraft and satellites. More recently, some military space surveillance systems have been used to track near-Earth asteroids and other objects that might pose impact risks. The technical capability to observe 3I Atlas in great detail, far greater than what is possible with most civilian telescopes, almost certainly exists within the classified satellite systems operated by the National Reconnaissance Office and other elements of the intelligence community. If the CIA determined that 3I Atlas represented a potential security concern, if they took seriously even a small probability that this object might be something other than a natural comet, then it is nearly certain that they would have tasked their most capable surveillance assets to observe it. They would have gathered the highest resolution imagery possible. They would have analyzed the object across multiple wavelengths of the electromagnetic spectrum. They might have looked for thermal signatures, patterns of outgassing, surface features, structural details, or any other characteristics that could provide insight into the object's nature. And if they did conduct such observations, what did they find? Did they confirm to their satisfaction that 3I Atlas is indeed natural, but using capabilities and methods that remain classified and which they have no intention of publicly disclosing? Did they find something ambiguous, something that neither clearly rules out nor confirms the possibility of artificial origin? Or did they find something more troubling, something that would justify continued classification and the use of a Glomar response to avoid any public discussion? We simply do not know, and given the CIA's response to the Black Vault's request, we may never know unless the agency is eventually compelled through appeals or litigation to provide more detailed information. The Trojan horse scenario, a security perspective. One plausible explanation for CIA interest in 3I Atlas involves what might be called the Trojan horse scenario, a reference to the ancient Greek stratagem in which a hollowed wooden horse, concealing enemy soldiers, was brought inside the walls of Troy, leading to the city's downfall. In the context of an interstellar object, this scenario would involve the possibility that 3I Atlas might be a disguised threat, either an intentional deception or a reconnaissance platform designed to gather information about our solar system and our civilization while presenting the appearance of a natural astronomical body. This is not wild speculation or science fiction fantasy. It is a legitimate threat scenario that any intelligence agency tasked with protecting national security should at least consider and evaluate when confronted with an anomalous object entering our solar system from interstellar space. The potential consequences of failing to detect such a threat, should it exist, would be severe enough to justify devoting resources to investigation, even if the assessed probability is quite low. Imagine, from the perspective of a CIA analyst tasked with thinking about unconventional threats, what 3I Atlas might represent if it were indeed artificial. An interstellar probe designed for long-duration missions would likely need to disguise itself as a natural object to avoid detection and potential destruction by any civilizations it encountered. Creating such a disguise might involve coating itself in ice and rocky material to mimic a comet, potentially even engineering controlled outgassing to produce the thermal and visual signatures we would expect from a natural object warmed by solar radiation. Such a probe might be gathering detailed information about our planet, our atmospheric composition, our radio and television broadcasts, our military capabilities, our technological level, our political divisions. It might be assessing whether humanity represents a potential threat, a future trading partner, a subject for study, or something else entirely according to motivations we cannot predict. Or it might simply be conducting a comprehensive survey of solar systems throughout the galaxy for purposes that have nothing to do with humanity specifically. If the CIA took the Trojan horse scenario seriously enough to investigate it, they would have wanted to gather as much information as possible about 3I Atlas using their most sophisticated surveillance capabilities. They would have conducted detailed analysis looking for any signs of artificial structure, active systems, course corrections, or other indicators that might distinguish a technological artifact from a natural object. And critically, they would want to do all of this without publicly revealing that they were conducting such an investigation, because confirming or denying such an investigation would itself reveal information about intelligence capabilities, priorities, and assessments. This scenario could explain both the CIA's use of a GLOMAR response and their apparent interest in an object that NASA publicly describes as clearly natural. Perhaps the CIA did investigate, found nothing that definitively proved artificial origin, but also nothing that entirely ruled it out, and chose to keep both the investigation and its ambiguous result classified to avoid public alarm and to protect the capabilities they used to conduct the investigation. Revealing capabilities. Why classification might persist. Another explanation for the CIA's GLOMAR response, perhaps more mundane but equally significant, involves the protection of surveillance capabilities rather than the concealment of any particular conclusions about 3I Atlas itself. Intelligence agencies are extraordinarily protective of information about their technical capabilities, the methods they use to gather information, and the performance specifications of their surveillance systems. This is true even when the information gathered using these systems might not itself be particularly sensitive. Consider the possibility that the CIA tasked advanced reconnaissance satellites and telescopes to observe 3I Atlas, not necessarily because they concluded it was likely to be artificial, but simply as a precautionary measure or as an opportunity to test and demonstrate their capabilities in tracking and characterizing a fast-moving object entering from interstellar space. Such observations might have revealed nothing particularly surprising, confirming that 3I Atlas appears consistent with a natural comet showing some unusual but ultimately explicable properties. However, even this relatively benign conclusion could not be publicly disclosed without also revealing details about the surveillance platforms used to reach it. Describing what they observed would necessarily reveal the resolution of their imaging systems, the wavelengths they can observe, the tracking accuracy of their telescopes, and other technical parameters that the intelligence community prefers to keep classified. Adversarial nations could use this information to better understand American surveillance capabilities and to develop countermeasures or strategies for evading observation. From this perspective, the GLOMAR response protects not what was learned about 3I Atlas, but rather what learning anything about 3i Atlas would reveal about intelligence sources and methods. This explanation is consistent with the specific language used in the CIA's response, which explicitly invokes Section 6 of the CIA Act of 1949, the statutory provision specifically designed to protect intelligence sources and methods from disclosure. If this explanation is correct, it suggests that the CIA may indeed have studied 3i Atlas, may have concluded it is most likely natural, but cannot say so publicly without compromising classified capabilities. This would represent a frustrating outcome from a transparency perspective. Information about an astronomical object that poses no threat being withheld for legitimate, but purely technical reasons related to protecting surveillance systems. But it would at least be consistent with both NASA's public confidence and the CIA's refusal to confirm or deny. The precedent of declassification when GLOMAR protections fall. The history of CIA GLOMAR responses provides some reason for guarded optimism that more information about 3i Atlas may eventually become available, even if not immediately. While many GLOMAR responses successfully shield information from disclosure indefinitely, there are notable examples where sustained legal pressure, changing circumstances, or the simple passage of time have eventually led to at least partial declassification. The most instructive example comes from the case of ACLU versus CIA, decided in 2013, which involved Freedom of Information Act requests seeking CIA records about United States drone operations in Pakistan, Yemen, and other countries. The CIA initially responded with a GLOMAR refusal, arguing that confirming or denying the existence of records about drone programs would reveal classified intelligence activities and methods. This position, if upheld, would have completely shielded the drone program from any public accountability or legal scrutiny through Freedom of Information Act channels. However, the D.C. Circuit Court of Appeals ultimately rejected this GLOMAR assertion, finding it neither logical nor plausible in light of extensive public statements by senior government officials that had already acknowledged the existence of the drone program and CIA's role in it. President Obama had discussed drone strikes in public remarks. CIA Director Leon Panetta and senior White House advisor John Brennan had made statements that confirmed the program's existence. Given these official admissions, the court held that the CIA could not simultaneously claim that confirming the existence of relevant records would compromise intelligence secrets. This case established important precedent that GLOMAR protections can be overridden when government officials have already publicly acknowledged the essential facts that the intelligence agency seeks to protect through its neither confirm nor deny stance. Following the court's decision, the CIA was compelled to declassify and release at least some documents related to the drone program, though many records remained redacted or withheld under other exemptions. Could a similar trajectory occur with 3i Atlas? The answer may depend on what, if anything, NASA and other government officials say publicly about any potential intelligence community interest in this object. If senior officials make statements that effectively acknowledge that surveillance assets were used to observe 3i Atlas, or if they provide details about its characteristics that could only have been obtained through classified observation systems, then any GLOMAR claim becomes harder to sustain. On the other hand, if officials maintain careful silence about any intelligence dimension while NASA continues to discuss 3i Atlas purely as a scientific matter, the classification may be more defensible. The Black Vault's decision to appeal the GLOMAR response suggests they believe there may be grounds for challenging it, though the specific legal arguments they will advance remain to be seen. The appeal process can take months or even years to work through administrative and potentially judicial review, but it represents the best available mechanism for testing whether the CIA's classification claims can withstand scrutiny. The persistent ANTI tale, returning to the physical evidence. While the bureaucratic intrigue surrounding CIA classification and Freedom of Information Act requests provides compelling context for understanding the institutional response to 3i Atlas, we must not lose sight of the fundamental physical observations that make this object genuinely anomalous regardless of what intelligence agencies may or may not be investigating. The anti-tail phenomenon represents a real, documented, measurable characteristic that demands explanation within the framework of cometary physics and solar system dynamics. To appreciate why this matters so profoundly requires understanding what we mean by an anti-tail and why such a feature is so difficult to reconcile with conventional cometary behavior. When a comet approaches the inner solar system, its nucleus, typically composed of frozen water, carbon dioxide, methane, and other volatile compounds mixed with rocky and carbonaceous material, begins to warm under the increasing intensity of solar radiation. This warming causes the frozen volatiles to sublimate, transforming directly from solid to gas without passing through a liquid phase. This outgassing creates what we observe as the comet's coma and tail. The coma is the roughly spherical cloud of gas and dust immediately surrounding the nucleus, while the tail, or tails, extend away from the nucleus in the direction opposite the sun. This directionality is not incidental or approximate. It is an ironclad rule of cometary physics driven by two mechanisms: radiation pressure from sunlight pushing on dust particles and the solar wind, a stream of charged particles flowing outward from the sun, pushing on ionized gas molecules. These forces always point away from the sun. Always. There are no known conditions within our solar system under which the solar wind reverses direction or sunlight pushes objects toward rather than away from the sun. Therefore, any comet tail should always point away from the sun, creating a beautiful visual marker that traces the direction of solar radiation and solar wind flow at the comet's location. An anti-tail, a tail extending toward the sun rather than away from it, represents something fundamentally different. In conventional cometary science, features that superficially resemble anti-tails have occasionally been observed, but these are invariably explained as projection effects. When Earth's viewing angle aligns in specific ways with a comet's orbital geometry, dust particles that have been left behind in the comet's orbital path can create the visual illusion of a tail pointing toward the sun, even though the actual material is simply tracing the comet's prior trajectory through space. These projection effect anti-tails are typically faint, short-lived, and only visible under specific geometric configurations. They disappear or change dramatically as viewing angles shift. They are understood to be artifacts of perspective rather than actual structures extending from the nucleus toward the sun. The anti-tail of 3I Atlas does not fit this pattern. It is not a faint projection effect visible only at certain angles. It is a substantial, persistent structure extending hundreds of thousands to 1,000,000 kilometers in a direction that cannot be easily reconciled with known solar system forces. It has been observed repeatedly over extended periods, suggesting it is a stable feature rather than a transient geometric effect. Proposed explanations and their inadequacies. Various explanations have been proposed to account for 3I Atlas's anti-tail within the framework of natural phenomena, and it is important to consider these fairly before concluding that something truly anomalous is occurring. Scientific integrity requires examining whether conventional physics, perhaps applied in novel ways or accounting for subtle effects, might explain what we are observing. One suggestion involves asymmetric outgassing from the nucleus. If volatile materials are sublimating preferentially from one side of the object, perhaps due to uneven heating or compositional variations across the surface, this could create a jet effect that propels material in a particular direction. If this jet happened to be oriented approximately toward the sun, it might overcome the outward pressure of radiation and solar wind, at least in the immediate vicinity of the nucleus, creating what appears to be an anti-tail. This explanation faces several challenges. First, to produce an anti-tail extending hundreds of thousands of kilometers, the outgassing would need to be extraordinarily powerful and sustained. The velocities required to push material that far against solar wind and radiation pressure will be far higher than typical cometary outgassing velocities. Second, we would expect to see clear evidence of such powerful asymmetric outgassing in the form of detectable acceleration of the nucleus itself. Newton's third law demands that if the comet is ejecting material in one direction, it must experience a reaction force in the opposite direction. While some small non-gravitational accelerations have been detected in cometary orbits and attributed to outgassing, the forces required to produce 3I Atlas's anti-tail should produce much larger and more obvious orbital perturbations. Third, sustaining such directional outgassing over the extended period during which the anti-tail has been observed would require a substantial reservoir of volatile material. And it is unclear why this would preferentially sublime from the sun-facing side, where we would expect material to be most depleted by prior heating. Another proposed explanation involves magnetic effects. If 3I Atlas possessed a strong magnetic field, perhaps generated by some internal mechanism or remnant from its formation, this field might interact with the solar wind in ways that could channel ionized material into unexpected trajectories. The solar wind consists of charged particles, and charged particles respond to magnetic fields through the Lorentz force, potentially creating complex flows that do not simply move radially away from the sun. This explanation is intriguing, but faces its own difficulties. First, comets are not typically magnetic. They lack the internal dynamo mechanisms that generate magnetic fields in planets like Earth, and their composition does not generally include the kinds of ferromagnetic materials that could produce strong permanent magnetic fields. Second, even if 3I Atlas somehow possessed an anomalous magnetic field, it is unclear whether such a field could overcome the dominant outward pressure of the solar wind to create the observed anti-tail. Magnetic interactions with the solar wind do create interesting structures around comets, including bow shocks and ion tails with complex shapes, but these phenomena are well studied and do not typically produce anti-tails of the observed magnitude and persistence. Third, a magnetic field strong enough to produce such effects should be detectable through other means, including effects on the local plasma environment and on any spacecraft that might pass through the region. Yet no such magnetic signatures have been reported. A third class of explanations involves exotic compositional hypotheses. Perhaps 3I Atlas consists of materials not previously encountered in cometary nuclei, substances with unusual optical properties or outgassing behavior that could create the appearance of an anti-tail through mechanisms we have not yet identified. Perhaps the object contains clathrate hydrates, cage-like molecular structures that trap other molecules, that release their contents in unexpected ways as temperature and pressure conditions change. Perhaps there are photochemical reactions occurring in the coma that produce unanticipated dust distributions or optical effects. These explanations have the advantage of being difficult to definitively rule out, since we have only limited spectroscopic data about 3I Atlas's composition and cannot directly sample its materials. However, they suffer from being largely ad hoc. They postulate exotic, never-before-seen materials or processes specifically to explain 3I Atlas without independent evidence that such materials or processes actually exist. This does not make them wrong, but it does make them scientifically unsatisfying in the absence of supporting observations. The artificial hypothesis, taboo but logical. There is one explanation for 3I Atlas's anti-tail that would straightforwardly account for its properties without requiring exotic natural phenomena or implausible physical configurations: artificial directionality. If 3I Atlas is not a natural object, but rather some form of technological artifact, then an anti-tail could be explained as exhaust or waste products being expelled in a controlled direction as part of the object's operation or propulsion. This explanation is rarely discussed in mainstream astronomical literature, not because it is physically implausible, but because it violates strong professional norms against invoking artificial explanations for astronomical phenomena unless absolutely necessary. This taboo has sound historical justification. The history of astronomy is littered with examples of phenomena that initially seemed mysterious and potentially artificial, but were eventually explained through natural processes once better understood. The discipline has learned to be extremely conservative about entertaining artificial explanations, demanding extraordinary evidence before seriously considering such hypotheses. However, Conservatism can become counterproductive when it prevents honest consideration of explanations that might actually account for observed data better than the natural alternatives. If 3I Atlas were indeed artificial, a probe, a monitoring station, a derelict spacecraft, or something else we cannot readily categorize, then many of its puzzling characteristics would make more sense than they do under the assumption of natural origin. An anti-tail could be explained as directional exhaust from propulsion systems, waste heat and matter being expelled in a specific direction for thermal management or momentum control. The persistence and substantial length of the anti-tail could reflect the continuous or intermittent operation of such systems over extended periods. The fact that this directional ejection appears to point approximately toward the sun might relate to the object's orientation, navigation requirements, or solar energy collection, if indeed the object is using solar power. Moreover, an artificial origin could potentially explain other anomalies that have been noted in 3I Atlas's behavior beyond just the anti-tail. Any trajectory adjustments, unusual spectroscopic signatures, or other characteristics that do not neatly fit natural comet models might all be consistent with a technological object operating according to principles and purposes we do not understand. The great challenge with the artificial hypothesis is not that it fails to explain the observations. In some respects, it explains them more parsimoniously than exotic natural alternatives, but rather that it carries enormous implications that extend far beyond astronomy. Confirming that even a single interstellar object is artificial would fundamentally transform our understanding of life in the universe, the prevalence of technological civilizations, the possibility of contact or interaction, and ultimately humanity's place in the cosmic context. These implications are so profound that the evidentiary bar for accepting such a conclusion must be correspondingly high, and current observations of 3I Atlas, while certainly anomalous and deserving of careful attention, probably do not yet clear that bar for most scientists. NASA's confidence. Understanding the institutional position. NASA's public stance on 3I Atlas. Their confident assertion at the November 19, 2025 press conference that this is definitely a comet of natural origin deserves careful examination in light of the anomalies we have discussed and the CIA's apparent interest in the object. How can NASA be so certain? What is the basis for their confidence? NASA's position rests primarily on the fact that 3I Atlas displays many characteristics consistent with cometary composition and behavior. Spectroscopic observations show signatures of water vapor, carbon-based molecules, and other materials typical of comets. The object displays a coma and experiences outgassing, both expected behaviors for a comet warming as it approaches the sun. Its overall brightness and visual appearance largely match what would be expected for a comet of its estimated size at its distance from the sun. From NASA's institutional perspective, these observations constitute strong positive evidence for natural origin. When an object looks like a comet, acts like a comet, and is composed of cometary materials, the default conclusion within astronomical practice is that it is indeed a comet unless there is compelling evidence to the contrary. The anomalies, the anti-tail, certain trajectory peculiarities, perhaps some unexpected spectroscopic details, are acknowledged but treated as interesting puzzles to be resolved through further observation and refinement of models rather than as fundamental challenges to the natural origin hypothesis. This approach reflects how scientific institutions typically operate, and for good reason. Science progresses by building on established knowledge, extending and refining theories rather than discarding them at the first sign of anomalous data. The history of science shows that most anomalies are eventually resolved within existing frameworks once better data is obtained or more sophisticated modeling is applied. Revolutionary paradigm shifts that overturn established understanding do occur, but they are rare, and institutions are right to maintain high evidentiary standards before embracing such shifts. However, institutional conservatism can also produce blind spots. When organizations have strong incentives to provide reassuring, definitive answers, and space agencies certainly face such incentives, particularly regarding potential threats or disturbing possibilities, there's a risk of overstating confidence and downplaying legitimate uncertainties. NASA's unequivocal statement that 3I Atlas is definitely natural may reflect genuine scientific consensus, or it may reflect institutional preference for certainty and closure even when the evidence is more ambiguous than publicly acknowledged. The contrast between NASA's public certainty and the CIA's classification response suggests possible gaps between different parts of the government's knowledge or assessment of 3I Atlas. Either different agencies are working with different information, or they're applying different frameworks and reaching different conclusions about the same information, or one agency is being more forthcoming publicly than the state of knowledge actually warrants. The broader context: interstellar objects and detection capabilities. 3I Atlas exists within a broader context of humanity's rapidly evolving capability to detect and characterize interstellar objects passing through our solar system. Until very recently in astronomical history, we lacked the observational capabilities to reliably detect such objects at all. Our telescopes were not sensitive enough, our survey programs were not comprehensive enough, and our automated detection algorithms were not sophisticated enough to distinguish fast-moving interstellar visitors from the much more numerous asteroids and comets native to our own solar system. This began to change with the development of programs like PanSTARRS, Panoramic Survey Telescope and Rapid Response System, the Catalina Sky Survey, and other automated survey programs designed primarily to detect potentially hazardous near-Earth asteroids, but capable of catching interstellar interlopers as well. The detection of Oumuamua in 2017 represented the first time humanity definitively identified an object as having originated from beyond our solar system, though in retrospect it seems likely that interstellar objects had passed through undetected many times before. Since Oumuamua, our detection capabilities have continued to improve. New survey telescopes with larger mirrors and more sensitive detectors are coming online. Automated data processing pipelines are becoming more sophisticated at identifying unusual objects. The Vera C. Rubin Observatory, currently under construction in Chile, will revolutionize our ability to detect transient astronomical phenomena, including interstellar objects, when it begins full operations. This means that the small number of identified interstellar objects, Oumuamua, 2I/Borisov, 3I Atlas, and potentially a few others depending on how one categorizes ambiguous cases, almost certainly represents a tiny fraction of the interstellar objects that actually pass through the inner solar system. We are only now developing the ability to detect these visitors reliably, and our current sample is heavily biased toward the brightest, largest, or most unusual objects that stand out in survey data. This context is important for assessing 3I Atlas. If interstellar objects are relatively common, perhaps dozens or hundreds passing through the inner solar system per year, with only the most unusual being detected, then encountering one with anomalous properties may not be as surprising as it initially appears. We might expect a certain percentage of interstellar visitors to have unusual compositions, formation histories, or structural properties that make them stand out from the more typical comets and asteroids we are familiar with from our own solar system. On the other hand, if truly anomalous properties like 3I Atlas's antitail are exceptionally rare even among interstellar objects, if most interstellar visitors behave much more conventionally once we detect them, then the anomalies take on greater significance. They suggest we may be seeing something genuinely unusual rather than simply the expected diversity of natural objects. The technology gap, what we cannot yet detect. Any honest assessment of our current observational capabilities must acknowledge their significant limitations. Even with modern telescopes and space-based observatories, there's an enormous amount we cannot determine about interstellar objects like 3I Atlas, particularly when they're discovered relatively late in their passage through the inner solar system when they are already receding and fading. Our ability to determine the size of such objects is limited and based largely on assumptions about their albedo, reflectivity. We estimate size by measuring how much light an object reflects and assuming a typical albedo value. But if the actual albedo is significantly higher or lower than assumed, our size estimates could be off by factors of 2 or more. This matters because many other properties, mass, gravitational effects, surface area available for outgassing, scale with size. Our spectroscopic capabilities, while impressive, can only detect molecules and elements that produce distinctive signatures in the wavelengths we can observe. Many materials produce broad, non-distinctive absorption or emission features that are difficult to identify conclusively. Complex organic molecules, certain metals and alloys, and crystalline structures might not produce easily recognizable signatures, leaving significant ambiguity about surface and bulk composition. Our ability to determine detailed surface properties, topology, texture, structural features, small-scale irregularities, is extremely limited at the distances involved. Even our best space-based telescopes cannot resolve interstellar objects into more than a handful of pixels at most. We cannot see what the surface actually looks like in the way we can with nearby asteroids and comets that spacecraft have visited. Any structure smaller than hundreds of meters across would be completely invisible to current observations. Our capacity to detect subtle trajectory adjustments or non-gravitational accelerations exists, but is limited by measurement precision and the length of the observation baseline. Small course corrections, if timed appropriately, might be misattributed to outgassing or lost in the noise of measurement uncertainty. An object capable of adjusting its trajectory through small, carefully applied thrust could potentially do so without leaving obvious evidence in the orbital data we collect. Perhaps most significantly for questions about possible artificial origin, we have very limited capability to detect many kinds of technosignatures that might be present. Our radio telescope observations cover only tiny fractions of time and frequency space. We cannot detect waste heat that might indicate active systems unless it is substantial enough to significantly affect the object's thermal signature. We cannot detect compact, shielded power sources or inactive systems. We cannot identify manufactured materials unless they have distinctive spectroscopic signatures that happen to fall within wavelengths we are observing. This means that our confidence in classifying objects as natural based on current observations should be appropriately modest. We can say that 3I Atlas shows many characteristics consistent with natural origin. We can say that we have not detected any definitive technosignatures. But we cannot say with absolute certainty that no technological components or artificial aspects are present, because our observational capabilities have significant blind spots. The statistical argument. How often should this occur? One approach to assessing the significance of 3I Atlas's anomalies involves considering the statistics of interstellar objects and asking how often we should expect to encounter such unusual characteristics if all interstellar visitors are natural objects following understood physical principles. This statistical approach faces immediate challenges because our sample size is so small. We have confidently identified only a handful of interstellar objects, which is far too few to establish reliable statistical baselines. We do not know what the typical interstellar object looks like or behaves like because we do not yet have a large enough sample to define typical. Every object we detect reveals new aspects of the diversity that exists among bodies originating from other star systems. However, we can make some rough assessments based on our knowledge of comets and asteroids from within our own solar system. If interstellar objects are, as most astronomers assume, broadly similar to solar system bodies in their formation and composition, then the vast majority should display relatively conventional behavior once we account for their different formation environments and potentially unusual compositions. Anti-tails of the magnitude and persistence shown by 3I Atlas, if they are truly sui generis rather than conventional projection effects misidentified, should be extraordinarily rare. Among the thousands of comets observed throughout history, the number showing genuine anti-tail behavior that cannot be explained through geometric effects is effectively zero. If interstellar objects follow similar physics, then encountering one with a prominent, persistent anti-tail in only the third or fourth interstellar object definitively identified seems statistically surprising. This reasoning is not conclusive. With a sample size of 3 or 4, Even outcomes with 10% probability will occasionally appear, and we might be seeing exactly that kind of statistical fluctuation rather than evidence of anything more significant. But it does suggest that 3I Atlas deserves careful ongoing attention rather than quick dismissal as simply another comet with a few interesting quirks. The statistical picture will become clearer as more interstellar objects are detected and characterized over the coming years and decades. If anti-tails and other anomalies prove to be relatively common among interstellar visitors, then 3I Atlas will be recognized as unusual, but not uniquely so, and we will need to expand our models of natural cometary behavior to accommodate a wider range of phenomena. If, on the other hand, most interstellar objects behave quite conventionally and 3I Atlas remains an outlier, then the case for deeper investigation of its nature becomes stronger. The question of origin. Where did it come from? Understanding 3I Atlas also requires considering where it came from before entering our solar system, and what this might tell us about its nature and history. Interstellar objects arrive with specific velocity vectors that can, in principle, be traced backward to determine their direction of origin. However, this backward integration faces significant complications because of the gravitational effects of nearby stars, the motion of stars through the galaxy, and the long timescales involved. Preliminary trajectory analyses of 3I Atlas suggest that it may have originated from the general direction of the galactic center, though with substantial uncertainties. If accurate, this would place its origin in one of the most densely populated regions of the Milky Way galaxy, where stars are more closely packed than in our Sun's current location in the galactic suburbs. A higher stellar density means that planetary systems are more likely to gravitationally interact with passing stars, potentially ejecting objects into interstellar space at higher rates than occurs in sparser regions. This direction of origin could be entirely consistent with a natural explanation. The galactic center regions presumably produce and eject comets and asteroids, just as star systems elsewhere do, and the higher density might actually make such ejection events more common. However, it also represents a region where, statistically, we might expect a higher density of technological civilizations if they exist at all, simply because there are more stars and presumably more planets. The distance of origin matters critically for any hypothesis involving artificial origin. If 3I Atlas originated relatively nearby, within, say, 100 light-years, then a technological origin becomes somewhat more plausible because the travel time, even at interstellar velocities of tens of kilometers per second, would be only tens of thousands of years, conceivably within the operational lifetime of a well-designed probe. If the origin is much more distant, measured in thousands or tens of thousands of light-years, then mission durations stretch into millions of years, which poses severe challenges for any technological artifact we can currently imagine. Unfortunately, tracing the precise origin of interstellar objects is extraordinarily difficult. The positions and velocities of stars change over the millennia, and reconstructing the exact stellar neighborhood that existed when 3I Atlas began its journey requires sophisticated modeling of galactic dynamics. The result is that we can typically only narrow the origin to a large region of the sky rather than pointing to a specific star system, which limits how much we can infer about the object's history. The temporal dimension. How long has it been traveling? Related to the question of origin is the question of how long 3I Atlas has been traveling through interstellar space before arriving in our solar system. This duration depends on both the distance traveled and the object velocity, but estimating it requires knowing both parameters with precision we generally lack. If 3I Atlas is traveling at typical interstellar velocities, perhaps 20 to 30 kilometers per second relative to nearby stars, and originated from the galactic center region at a distance of roughly 25,000 light-years, then the journey time would be measured in billions of years. This is longer than complex life has existed on Earth, longer than our Sun's current age. For a natural object, such timescales present no particular problem. Ice and rock can survive in the cold of interstellar space essentially indefinitely, preserving their structure and composition for galactic rotation periods. For an artificial object, However, travel times measured in billions of years present extraordinary challenges. All materials degrade over time, particularly when exposed to cosmic radiation, micrometeorite impacts, and the occasional close stellar encounter. Electronic components fail, mechanical systems wear out, power sources deplete, information storage degrades. Designing any technological artifact that could remain functional or even structurally intact over such timescales would require capabilities far beyond anything humanity has achieved or even seriously conceived. This temporal consideration provides one of the stronger arguments against the artificial hypothesis, at least for origins in the distant galactic center. If 3I Atlas is technological, it would need to have originated from a much closer source. Close enough that the travel time is measured in hundreds of thousands, or at most millions of years rather than billions. This substantially constrains where it could have come from and suggests that if artificial, it would need to have originated from one of the Sun's relatively nearby stellar neighbors. Alternatively, an artificial object might employ strategies we have not considered. Perhaps it spends most of its journey in a dormant state, activated only when approaching a star system. Perhaps it is capable of self-repair using materials collected en route. Perhaps it uses technologies for preserving information and functionality that we cannot currently imagine. These possibilities cannot be entirely ruled out, but they require stacking speculative assumptions upon one another, which weakens the argument. The communication challenge. Should we expect signals? The SETI observations of 3I Atlas and the absence of detected narrowband radio signals raise important questions about what we should expect from a hypothetical interstellar probe in terms of communication and transmission behavior. Our assumptions about what artificial objects should do are necessarily shaped by human technology and human purposes, which may have limited relevance to artifacts created by fundamentally different intelligences with different priorities, capabilities, and circumstances. Human spacecraft designed for deep space missions do maintain regular communication with Earth, transmitting scientific data, engineering telemetry, and occasionally receiving commands for course corrections or instrument operations. This pattern makes sense for missions that operate on human timescales, where mission controllers and scientists are alive throughout the mission duration, and where the light travel time for communications is measured in hours or at most days. But interstellar missions operate under entirely different constraints. If 3I Atlas is a probe sent by a civilization located even the nearest plausible distance away, tens or hundreds of light years, then the round-trip communication time is measured in decades to centuries. The civilization that launched it has long since evolved, changed, perhaps even ceased to exist by the time any signals could return. The scientists and engineers who designed and built the probe are certainly long dead. No meaningful operational control is possible across such distances and timescales. Under these circumstances, what communication strategy would make sense? Continuous transmission would consume energy, whether solar power or some onboard source, without providing any operational benefit, since no response could arrive in time to matter. A more efficient approach might involve no transmission at all, with the probe designed to operate autonomously and return data only if it eventually returns home or encounters another probe from the same civilization. Rare, high-energy bursts at long intervals, perhaps triggered by specific mission events or milestones. Beamed, directional transmission aimed only at specific targets, such as the origin civilization's home system, rather than omnidirectional broadcasts. Use of communication technologies that do not rely on radio waves, perhaps optical lasers, modulated gravitational waves, quantum entanglement systems, or methods we have not yet discovered. Any of these strategies would result in exactly what SETI observations have found: no detectable radio signals during the brief observation windows available to us. The absence of detected signals thus tells us very little about whether 3I Atlas is artificial or natural, unless we are prepared to assume that any extraterrestrial technology must operate according to principles and priorities that match human expectations. The precedent concern: what if we're wrong? Underlying many of the discussions about 3I Atlas particularly in official government and institutional contexts, is an unstated concern about precedent. How we classify this object, what we conclude about it, and how we communicate these conclusions to the public will establish templates for how similar situations are handled in the future. This creates incentives for conservatism and for resolving ambiguity in favor of conventional explanations, even when the evidence might be more equivocal than publicly acknowledged. If 3I Atlas were to be officially recognized as potentially artificial, if NASA, the CIA, or other authoritative institutions were to state publicly that they cannot rule out technological origin and that the anomalies observed warrant serious consideration of this possibility, the consequences would be substantial. Public attention would intensify dramatically. Demands for more comprehensive investigation and greater transparency would proliferate. Other nations might announce their own observations or assessments, creating a complex international situation. Speculation about the origin, purpose, and implications of an interstellar probe would dominate public discourse. For institutions that prize stability, predictability, and control over narrative, such outcomes are deeply unappealing even if the underlying scientific question remains genuinely open. There are strong bureaucratic and political incentives to declare the matter settled, to assure the public that everything is understood and under control, even if privately some uncertainty remains. This does not require conspiracy or deliberate deception. It simply reflects how large institutions operate when confronting ambiguous situations with potentially significant consequences. The default institutional response is to resolve ambiguity in favor of whatever interpretation allows normal operations to continue, maintains public confidence, and avoids opening difficult questions that resist easy answers. Understanding these institutional dynamics is essential for interpreting official statements about 3I Atlas. NASA's confident assertion of natural origin may represent genuine scientific consensus, or it may represent an institutional preference for closure that runs ahead of what the evidence actually supports. The CIA's classification response may indicate deep secrets about troubling findings, or it may simply reflect routine protection of surveillance capabilities combined with bureaucratic risk aversion about acknowledging any institutional interest in the matter. The public's right to know. Transparency considerations. The tension between institutional preferences for control and public interest in transparency forms a critical subtext to the entire 3I Atlas situation. Citizens of democratic societies have a legitimate interest in knowing what their government have learned about significant phenomena, particularly phenomena that could potentially have implications for human safety, security, or understanding of our cosmic context. The Freedom of Information Act and similar transparency laws in other democracies exist precisely to provide mechanisms for public access to government information balanced against legitimate needs to protect national security, personal privacy, and certain other interests. The Black Vault's decision to submit a FOIA request about 3I Atlas and their decision to appeal the CIA's GLOMAR response represents the transparency system working as intended, citizens using legal tools to push back against government secrecy and demand justification for classification decisions. However, this system works imperfectly. Intelligence agencies have substantial advantages in these disputes, including resources to litigate for years, control over what information is classified in the first place, and broad deference from courts on matters touching national security. While egregious overclassification can sometimes be successfully challenged, agencies win a substantial majority of these disputes, particularly when they can articulate even minimally plausible sources and methods rationales for withholding information. The result is that critical information about 3I Atlas may remain classified indefinitely, not because its disclosure would genuinely harm national security, but because the legal and bureaucratic mechanisms for challenging classification are cumbersome and heavily weighted in favor of secrecy. If the CIA observed 3I Atlas using advanced reconnaissance satellites and concluded it is natural but unremarkable, that conclusion cannot be made public without revealing details about satellite capabilities. If they found something more ambiguous or troubling, they have even stronger reasons to maintain classification. Either way, the public may never learn what intelligence agencies actually know. This situation is frustrating but reflects genuine tension between legitimate competing interests. The same surveillance capabilities that might be used to observe astronomical phenomena are also used to monitor military threats, and protecting details about those capabilities serves real national security purposes. The challenge is establishing appropriate oversight and accountability mechanisms that can verify that classification decisions are made for legitimate reasons rather than bureaucratic convenience, without compromising the very capabilities that classification is meant to protect. Scientific process versus public interest, different timescales. Another source of tension in the 3I Atlas situation arises from a mismatch between scientific timescales and public attention spans. From a scientific perspective, resolving mysteries about anomalous objects requires patient accumulation of data, careful analysis, theoretical development, and peer review, processes that often take years or decades. Preliminary observations yield initial hypotheses that are refined through subsequent observations and analysis. Competing explanations are proposed and tested against new data. Consensus emerges gradually as evidence accumulates, and the community converges on interpretations that best explain all available observations. This measured, deliberate process serves science well. It prevents premature conclusions, allows careful vetting of claims, and produces robust knowledge that has been thoroughly examined from multiple perspectives. But it operates on timescales that are difficult to reconcile with modern public discourse, where news cycles measure attention in hours or days, and audiences demand definitive answers to emerging questions. 3I Atlas presents a perfect example of this mismatch. From a scientific standpoint, the appropriate response to its anomalies is to continue gathering data, develop refined models, consider various hypotheses, and allow the community time to work toward consensus. This might take years, and intermediate states might involve irreducible uncertainty where multiple explanations remain viable. But from a public discourse perspective, such sustained uncertainty is difficult to maintain. Media organizations need to report on developments, which creates pressure to present conclusions even when scientists themselves remain uncertain. Audiences exposed to initial reports about anomalies naturally want to know what it all means, what the answer is, whether there's any danger or significance. And institutions like NASA face pressure to provide those answers, to reassure the public that experts have matters under control and know what is happening. The result is that public statements about scientific questions often convey greater certainty than actually exists within the scientific community itself. Nuance, qualification, and acknowledgement of uncertainty, all essential elements of honest scientific discourse, translate poorly into public communication, where they can be misinterpreted as evasion or incompetence. Scientists and institutions therefore face incentives to express confidence even when privately they might acknowledge significant unknowns. The role of individual scientists. Avi Loeb's position. Dr. Avi Loeb's public commentary on 3I Atlas deserves specific attention because it illustrates how individual scientists can sometimes play roles that institutions cannot or will not. As a prominent, tenured professor at a prestigious institution, Dr. Loeb has the professional security to raise questions and propose hypotheses that might be professionally risky for early career researchers or for scientists working within government agencies subject to institutional messaging discipline. Dr. Loeb has become known in recent years for his willingness to seriously discuss the possibility that anomalous astronomical objects might have artificial origins. His book, Extraterrestrial, which argued that Oumuamua characteristics were at least consistent with artificial origin and deserving of serious scientific consideration, generated substantial controversy within the astronomical community. Many colleagues criticized what they saw as premature speculation unsupported by sufficient evidence and irresponsible given the public attention such claims inevitably attract. However, Dr. Loeb's defenders argue that he is performing a valuable service by refusing to categorically rule out hypotheses that deserve at least consideration based on the evidence, even if those hypotheses challenge conventional assumptions. Science, they note, progresses not only through careful incremental refinement of established models, but also through occasional willingness to question fundamental assumptions and consider alternatives that might initially seem implausible. In the case of 3I Atlas, Dr. Loeb's commentary highlighting the contradiction between NASA's confidence and the CIA's classification response, and his thoughtful discussion of what the absence of radio signals actually does and does not tell us, serves to maintain public awareness that genuine unknowns remain. He is not claiming that 3I Atlas is definitely artificial. His statements are carefully qualified to avoid such overreach, but he is arguing that the anomalies are significant enough to warrant continued serious investigation rather than premature closure. This kind of individual scientific voice can serve as a useful counterweight to institutional tendencies toward consensus and certainty. Even if the majority of scientists ultimately conclude that Dr. Loeb's suspicions are unfounded and that 3I Atlas is indeed natural, his persistent questioning ensures that alternative possibilities remain part of the discussion and that anomalies are not simply dismissed or forgotten. Implications, if natural, expanding cometary theory. If 3I Atlas ultimately proves to be a natural object despite its anomalies, this outcome would still have significant implications for cometary science and our understanding of interstellar objects. The anti-tail and other unusual characteristics would need to be explained within the framework of natural processes, which would likely require expanding our theoretical models and incorporating phenomena that have not been previously observed or adequately described. This kind of theoretical expansion is how science normally progresses. Anomalous observations drive refinements to existing theories or occasionally prompt recognition that new physical processes need to be incorporated into our models. If 3I Atlas forces cometary scientists to develop better understanding of exotic outgassing mechanisms, magnetic effects in cometary coma, or other processes that can produce unusual observable features, this would represent valuable scientific progress. Such an outcome would also provide important context for interpreting future interstellar objects. If 3I Atlas's anomalies can be explained through natural processes, then encountering similarly unusual objects in the future should not immediately trigger speculation about artificial origin. We would have expanded the known range of what natural interstellar objects can look like and how they can behave. However, achieving this outcome requires actually developing those refined theoretical explanations and demonstrating that they quantitatively match the observations. Simply asserting that natural explanations must exist because artificial explanations seem unlikely does not constitute scientific explanation. The work of developing and testing refined models remains to be done, and until it is done successfully, the anomalies remain genuine puzzles rather than understood phenomena. Implications, if artificial, transforming our cosmic perspective. The alternative outcome, a determination that 3I Atlas is or might be artificial, would have implications so profound that they resist comprehensive enumeration. It would represent one of the most significant discoveries in human history, fundamentally transforming our understanding of life in the universe and our place within it. The most immediate implication would be confirming that technological civilizations exist or have existed elsewhere in the universe. This has long been suspected based on statistical arguments about the number of stars and planets. But statistical arguments are very different from empirical confirmation. Knowing with certainty that we are not alone, that intelligence and technology have arisen elsewhere, would shift this question from philosophical speculation to established fact. Second, detecting an interstellar probe within our solar system would provide information about the capabilities and strategies employed by the civilization that sent it. The mere existence of such a probe implies capabilities for interstellar mission design, long-duration systems, and resource investment on scales that might exceed anything humanity has achieved. Analyzing the probe's design, propulsion, materials, and operational characteristics could provide insights into an entirely different technological trajectory, potentially suggesting approaches to problems that human engineers have not yet conceived. Third, the existence of a probe raises questions about its purpose and whether it might be part of a larger program of exploration or communication. Is 3I Atlas simply gathering data about solar systems it passes through, or does it have more specific objectives? Is it part of a network of such probes distributed throughout the galaxy? Does it have any capability or inclination to communicate with civilizations it encounters, or is it designed purely for observation and data returned to its creators? Fourth, and perhaps most unsettling, the discovery of an interstellar artifact would raise questions about whether other such objects have visited our solar system previously, perhaps throughout Earth's history, without being recognized for what they were. If technological civilizations are capable of sending probes across interstellar distances, and if such probes have visited our solar system, then the galaxy may be far more populated and interconnected than we have assumed. What else might be out there that we have not yet detected or recognized? These implications explain much of the institutional conservatism about entertaining artificial hypotheses. The consequences of being correct would be so profound that extreme caution before reaching such conclusions is entirely appropriate. But the same considerations also suggest that if evidence pointing toward artificial origin does accumulate, it deserves the most serious possible consideration rather than reflexive dismissal. The path forward. What should happen next? Regardless of whether 3I Atlas ultimately proves to be natural or artificial, the situation clearly demonstrates the need for continued observation, investigation, and institutional transparency about what is known and what remains uncertain. From an observational standpoint, 3I Atlas should continue to be monitored as long as possible before it recedes beyond the sensitivity limits of available telescopes. Every additional data point, spectroscopic observations, astrometric position measurements, photometric monitoring of brightness variations, radio, and other wavelength observations, contributes to the overall picture and constrains possible explanations. The astronomical community should coordinate efforts to maximize the scientific return from this unique opportunity to study an interstellar object in detail. From a theoretical standpoint, serious work should be devoted to developing quantitative models that can explain 3I Atlas's observed characteristics within natural frameworks. If asymmetric outgassing, magnetic effects, or exotic compositional properties can account for the antitail, this should be demonstrated through detailed modeling that makes testable predictions for further observations. Similarly, if such natural explanations prove inadequate, this should be forthrightly acknowledged rather than simply asserting that natural explanations must exist. From a transparency standpoint, the Black Vault's appeal of the CIA's Glomar response should proceed through appropriate channels, and Congress might consider exercising its oversight authority to inquire what, if anything, intelligence agencies have learned about 3I Atlas using classified capabilities. While protecting genuine sources and methods is legitimate, mechanisms should exist to verify that classification is being applied appropriately rather than simply to avoid public scrutiny of embarrassing or inconvenient information. From a public communication standpoint, scientific institutions should strive to communicate openly about what is known with confidence, what remains uncertain, and what alternative explanations remain viable. This means resisting the urge to project false confidence or to declare matters settled when genuine uncertainty persists. It means acknowledging anomalies rather than minimizing them, while also maintaining appropriate skepticism about extraordinary claims pending extraordinary evidence. Conclusion. The story continues. 3I Atlas refuses to go away, and perhaps that is appropriate. It represents questions that deserve serious attention, anomalies that require explanation, and potentially implications that extend far beyond a single astronomical object passing through our solar system for a brief cosmic moment. The mainstream media may wish to move on to other stories, to declare this chapter closed and redirect public attention elsewhere. But the questions persist. The anti-tail continues to extend across hundreds of thousands of kilometers in defiance of straightforward cometary physics. The CIA continues to assert that even acknowledging whether they have information about this object would compromise intelligence sources and methods. The Black Vault continues to press for transparency through appeals and legal mechanisms. And observers like Dr. Avi Loeb continue to point out contradictions between official confidence and objective uncertainty. These are not the characteristics of a story that has reached its conclusion. They are the characteristics of a story still unfolding, where crucial information remains hidden, where explanations remain contested, and where the ultimate resolution remains uncertain. Whether 3I Atlas is ultimately understood as an unusual but natural comet, an artifact of technological intelligence, or something else entirely that does not fit neatly into either category, the truth remains to be established through continued observation, analysis, and hopefully greater transparency from institutions that possess information they have not yet disclosed. Until that resolution occurs, the responsible approach is to maintain attention, to continue asking questions, to refuse premature closure, and to insist on explanations that actually account for the anomalies rather than simply asserting that everything must be normal because abnormal outcomes seem unlikely. The universe has surprised us before and will certainly surprise us again. 3I Atlas may be one of those surprises, or it may prove to be a less significant anomaly than it currently appears. But we will not know which until the investigation continues to its proper conclusion, guided by evidence rather than institutional preference or preconceived assumptions about what we should find. The story of 3I Atlas continues, and we should be grateful for that continuation rather than accepting artificially imposed closure. In the questions it raises, in the mysteries it presents, and in the institutional responses it has provoked, this object provides a window into how humanity confronts the genuinely unknown and how our institutions navigate the space between public transparency and necessary secrecy. Whatever the ultimate answers prove to be, the process of seeking those answers reveals something important about our capabilities, our limitations, and our readiness to acknowledge possibilities that challenge comfortable assumptions about our cosmic solitude.